Hi everyone, and welcome to our channel. Today we'll be exploring some important features of the Piezo Buzzer and how you can build and code the sensor into your prototype. The Piezo Buzzer is an output device that uses a small magnetic coil to vibrate a metal disc inside a round plastic housing. By alternating current through the coil at different rates, different frequencies of sound can be emitted. The Piezo Buzzer can be used to create simple music or as an alarm for a variety of sensors. The Piezo Buzzer is polarized, which means there is a positive and a negative leg. To see which leg is positive and negative, look for the positive and negative sign underneath the Piezo Buzzer. You should also notice markings on the side of the Piezo Buzzer that also indicates which leg is positive. Now we're going to jump into how to build your Piezo Buzzer. For this activity, you'll need a Redboard, a breadboard, a Piezo Buzzer, a light sensor, a 10K ohm resistor, and 6 male-to-male jumper cables. To emit sound from the Piezo Buzzer when your surrounding environment becomes dark, follow the step-by-step diagram. Keep in mind of how your Piezo Buzzer is connected to the Redboard. The positive leg should be connected to digital pin 3, and the negative leg should be connected to the negative power rail on the breadboard, which is connected to the ground. Also be mindful of your light sensor and resistor. Make sure the jumper cables are all aligned correctly. Your light sensor should be connected to the 5 volts. Your resistor should also be in the same terminal strip of analog pin 0 and the negative power rail on the breadboard. After completing your build, now launch your Arduino IDE and add the following code into your sketch. The code roughly means the constant integer being declared will have a constant value and won't change. For example, the light pin will always be set to analog pin 0, and the sound pin will always be set to digital pin 3. When declaring a name to a specific pin number, be mindful of spelling, capitalization, and punctuation. Inside the curly brackets of the void setup, the serial begin will send data to the serial monitor at 9600 bits per second, and the pin mode establishes sound pin as an output. Inside the void loop, the light voltage, light pin, and serial print line all create a variable to store light voltage values. The if-else statement implies that if the light sensor is less than 650, your Piezo Buzzer will emit a tone at a frequency of 300 Hz. Else the tone will turn off. The delay will pause for 200 milliseconds before looping again. After completing your code, make sure the Redboard is connected to your computer using the USB connection. Also ensure your port is selected to the COM with the highest number. Once connected, you're ready to verify and upload your code. After uploading your code to the Redboard, confirm that your Piezo Buzzer is functioning correctly by hovering your hand over the light sensor to emit a sound. Now, move away to turn the sound off. Use your serial monitor to determine if your light sensor is dark enough to force the Piezo Buzzer to emit a sound. You can also change 650 to a lower value like 300 to easily make your Piezo Buzzer emit a tone when your surrounding environment is already dark. The voltage reading from the light sensor provides a value between 0 and 1023. So keep in mind higher numbers indicate a lower resistance and lower numbers indicate a higher resistance. If your Piezo Buzzer is not emitting a sound, don't worry. Recheck your wires to make sure your jumper cables are aligned with the positive and negative legs of your Piezo Buzzer. Also ensure that your light sensor is connected properly to the resistor. Thanks for watching, and please let us know if you have any questions in the comment section below, and be sure to check out our other videos on our First Nations Mesa channel.